Determinants of a matrix again, but this time we will look at only a 3 by 3, and we still use the cofactor method to set up the determinant, and we are going to see if there is a shortcut somewhere. So the first thing will be let A, B, C, D, E, F, G, H, I will be the entries of the 3 by 3. We already know how to use the cofactor method. So let's stick with the first row, using the first row to expand the determinant. So A, B, C will be the entries. So we know that the determinant of the matrix A will be A times the corresponding submatrix. So you cross out the first row and you cross out the first column. So you end up with E, F, H, I will be the submatrix for the entry A. B times the submatrix for B is cross out the middle column. So it'll be D, G, F, I for the B. Cross out the third column, D, E, G, H, D, E, G, H. So the determinant will be A times the corresponding submatrix minus B times the corresponding submatrix plus C times the corresponding determinant. I mean the determinant of the submatrix. So now we are going to expand the 2 by 2. So the determinant of A will be A times the quantity EI minus HF minus B times the quantity DI minus GF plus C times the quantity DH minus GE. And now we can distribute the ABC. So we have AEI, AHF, BDI, BGF, CDH, and CGE. And all I'm doing now is to simply group the 3 positive terms first, then the 3 negative terms. So I put AEI plus BGF plus CDH and minus CGE minus AHF and minus BDI. And if you look at the original determinant again and copy the first 2 columns, put them on the side, hey, there is a pattern. Turns out AEI is like the product of the entries along the first diagonal. BGF will be the entries along the second diagonal. CDH, the third diagonal, and they are all positive. If you go the other way, CEG, okay, and then AHF and BDI, and they will be negative. So this will be the shortcut method. A lot of engineering students will use this method to figure out the determinant. But this method only works for 3 by 3. And why not 4 by 4? Hey, try it then. Just like what I just did. Use the cofactor method, expand the 4 by 4 and see if you can find pattern. Most likely not. So let's for this particular podcast, we are going to use the shortcut method then. So the 3 by 3 will be 2, negative 3, 1 first column, 5, 1, negative 7, 6, negative 4, 1 will be the 3 by 3 matrix and the determinant. Now we copy the first 2 columns and put them on the side. So the shortcut method will be the following. You're going to carefully, okay, sometimes you can just eyeball the numbers. Sometimes you might, the first time, maybe you can draw the line. So you multiply 2 to 1 to 1. That's your first group. And then you multiply 5 to negative 4 to 1. That will be your second group. Third group will be 6 times negative 3, negative 7. And you add them up. Now you can go the other way. Will be 1 times 6 will be the next group, but it will be minus, negative. Minus negative 7 times a negative 4 times a 2. Minus 1 times a negative 3 times a 5. So now all you have to do is to multiply the numbers. So it'll be 2 minus 20, and then plus 6 times 3 is 18. 18 times 7 is 126. Minus 6, and then minus 7 times 4 is 28 times 2 is 56. Triple negative, so it'll be still negative. And then plus 3 times 5 is 15. So if you add them up, it's 61. Okay? Again, how do you know is the correct answer? Hey, you can use the cofactor method to expand, or you can also use the matrix. So I already took the screenshot of the matrix and then the determinant function. Here you go, 61. Okay, so we know that we get the correct answer. Two more examples. So actually, you should stop the podcast, do the problem, and come back and then check the answer. But I will continue. So again, what you're going to do with number 2, same thing. I just set up a general 3x3 matrix to let you practice. Okay, so let me get away from that one. So again, stack the first 2 columns nicely. And you're going to multiply numbers along the diagonal. So 7 times 6 times negative 3. First bunch. Negative 3 times 1 times negative 4. 2 times 0 times 5. You know, that will be 0 later on. And then minus the other group. Negative 4 times 6 times 2. Minus 5 times 1 times 7. And minus negative 3 times 0 times negative 3. So you know this will drop out also. So 7 times 6 times negative 3 is a negative 126. 3 times 4 is 12, but it's positive. Plus a 0. And then plus 4 times 6 times 2 will give you 48. Minus 35 minus 0. So the answer is 101. Negative. Okay. So again, I did the screenshot of the calculator, put in the matrix, and also the determinant is negative 101. Number 3, again, there was really no special, nothing special about the matrix, just to give you extra practice. So you should stop the podcast, do the problem, and then come back and check the answer. So again, stack the first 2 columns on the side. And you start multiplying 2 times 8 times 7. Negative 1 times negative 4 times 5. 3 times negative 3 times negative 9 will give you add them up. Minus 5 times 8 times 3. Minus negative 4 times negative 9 times 2. Minus 7 times negative 3 times negative 1. So, in fact, you can run your calculator and turns out the determinant equals to 0. Again, I put the matrix into the calculator and the determinant is indeed 0. And you should also always try to use the cofactor method and double check the answer. So I hope you enjoyed this little shortcut. But again, warning, it's only good for 3x3 matrix. Thank you.